All right, thanks for joining for this examples video. We've got 2 tangent theta plus 2 is equal to 0. So again, just solving this using our regular solving, what we need to do is get the trig function alone first. So I'm going to subtract 2. This is a negative, sorry, and divide by 2. So I get tangent theta is equal to -1. At that point, I now go and think about my unit circle. Tangent is -1 here and here. This angle is 3 pi fourths. This angle is 7 pi fourths. Then what you want to think about is the period of the function. So looking at tangent, the period here is just going to be pi, which means for each of these I could write n pi. And again, just representing that, I could be adding 1 pi, 2 pi, 3 pi, 4 pi, so on and so forth. So this is sort of an acceptable answer. I mean, yes, but it can actually be simplified. So it's not totally correct. The reason it can be simplified is because these, that's a terrible little bracket thingy. These are really giving the same answers. So giving the same answers. And if you don't believe me, think about like if I were to say n were 1 and add pi to this, what I would get is 7 pi fourths. So then after that, they're just going to continue giving the same answer. Graphically, what this looks like is I'm saying, okay, I have 3 pi fourths. I can go around like this, pi units, to get 7 pi fourths. And I can go around like that to get back here, pi units, to get, whatever this would be after 2 pi. But it's just going to keep bouncing between these 2 points that are always pi units away. So this overall can be simplified to just theta equals 3 pi fourths plus n pi. We usually go with the smallest positive angle, which is why we didn't take the 7 pi fourths. And again, this is just the way of like simplifying that answer. It will be something that you're going to have to work towards getting to. If you can get this, great, that's a great starting point. But then you want to also be thinking about, can it be simplified? And not all of them can. So looking at another one, we've got 3 cotangent squared x minus 1. So the first thing I'm going to do is add that 1. I get 3 cotangent squared x equals 1. And divide that 3. So cotangent squared x equals 1/3. Well, I don't know cotangent squareds on the unit circle, so I'm going to have to square root this. I get cotangent x equals, important thing here, if I'm going to be square rooting, this is going to give me plus or minus square root 1/3, which is cotangent x equals plus or minus 1 over square root 3. Now you might be thinking, oh, so I'm going to have to rationalize this. But no, not yet. Don't think about that yet. Because this is cotangent. And the problem is, if I'm going to now go to the unit circle, well, we didn't memorize the cotangents on the unit circle. So what you might want to do is think about this as tangent instead. And since I just changed this to tangent, I need to take the reciprocal of this. So that's going to give me plus or minus square root 3, and now I don't have to worry about that rationalizing. If you did rationalize this, you would have to re-rationalize it. Now I have tangent alone, so once I have the trig function alone, I can go to that unit circle. Positive and negative square root 3. So positive and negative square root 3 is going to happen in 4 locations. Here, 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 and here. So if I'm going to write my general solution, I can say x is equal to this angle, and let's just change color and you'll see why. This angle is pi thirds. plus the period of tangent is going to be n pi. And if I were to add pi to that, it would get me to this point. Remember that pi is essentially going to be just that straight line across going through the origin. Or, you can think about, okay, if I went around this whole semicircle, that's pi. So this point and this point are covered by this one general equation. Then I'd also have x equals these 2 points are also covered by one general equation because they are also pi units apart and pi units apart this way. It has to be a distance that will continue to cycle just between those points. This angle here is 2 pi thirds, and what I'm adding to it is just pi over and over. If I started here and added pi, I'd get here. And added pi again, I'd get here. Generally speaking, the issue that people have with this section is not the pi thirds, the 2 pi thirds, the solving. It's generally this period. Is it supposed to be n pi? Is it supposed to be 2n pi? And it changes problem by problem. All right, so let's go do some more examples of this. If I have sine squared x plus cosine x plus 1, so now we have a little bit of a trickier solving. The problem here is I have two different trig functions. But in 5.1, 5.2, I learned a way of rewriting sine as a function of cosine. So we said that sine squared is the same as 1 minus cosine squared x. And I'll bring everything else down, plus cosine x plus 1 equals 0. So that's going to give me negative cosine squared x plus cosine x plus 2, just combining those two ones. So I've got a trinomial now, and I'm just going to regular trinomial factor, but I'm going to have to take the negative out. So this becomes cosine squared x minus cosine x minus 2. And if I divide by that negative 1, now I just get cosine squared x minus cosine x minus 2 equals 0. This is factorable. Cosine x and cosine x. And I need numbers that multiply to negative 2 and add up to negative 1. Don't get thrown off by the fact that it's cosine. Think of it the same way as if it was x squared minus x minus 2. So I'll have negative 2 and positive 1. And what we've always done when solving these is now set each of these equal to 0. Cosine x plus 1 equals 0. Cosine x minus 2 equals 0. I get cosine x equals 2. And cosine x equals negative 1. Now, cosine x equaling 2, this never happens. There's no solution to that. And it's not the fact that this is not on the unit circle. It's the fact that cosine always bounces between negative 1 and positive 1. Again, think about that graph. It just goes in between negative 1 and positive 1. It's never equal to 2. Cosine x equaling negative 1, that does happen. So this is what we're using now. And at that point is when I can go to the unit circle. Cosine x is negative 1 only right here. So we would say that this angle, x, must be equal to this location, which is pi, plus the period in which it would repeat. So you can either think about that visually, like it's only repeating if I go around this whole thing, or you can just look at what the period on here is, which would be 2n pi. Only that answer, pi plus 2n pi. All right, moving forward. Solve for x if x is contained in 0 to 2 pi. So there's a domain restriction here. And verify the results using your calculator. This part of it we're going to have to talk about in class. But we've got cosecant squared equals 3 cosecant plus 4. So I'm going to move everything over to the left and have cosecant squared x minus 3 cosecant x minus 4 equals 0. And the reason I moved it over there is that now I'm going to be able to factor this. Again, just think of it as x squared and x. I would have cosecant x minus 4, cosecant x plus 1 equals 0. So here I get cosecant x is equal to 4. Cosecant x is equal to negative 1. I set those equal to 0 and solved them. I just didn't show it. Now again, if we're thinking about some of our unit circle stuff, we don't know cosecants. So I'm going to change these to sine. And because I'm changing them to sine, I'm taking the reciprocal. The reciprocal of negative 1 is negative 1. Now, this one is going to have to come straight from a calculator. But what we end up getting for that is x is approximately 0.253 and x is approximately 2.889. And it's going to be really easy to tell which ones of you, paid attention during this video, because I'm going to tell you right now, you do need to ask me how to get those, because you're only going to be able to get like this one. You're not going to necessarily know how to get that one. So you ask. I'm telling you right now, ask. Ask whoever your honors pre-calc teacher is. It doesn't have to be me. Sine x is equal to negative 1. Now this is from the unit circle, so we can do that one. Sine being negative 1 is right here. That angle is 3 pi halves. It would repeat every 2n pi. However, we're looking for only the answers between 0 and 2 pi. So I would get x equals 3 pi halves. And if I added one rotation to this, or one of the period to this, it would already be outside of that bound. So just x equals 3 pi halves. So three answers here. X equals 3 pi halves, approximately 0.253, and 2.889. Again, these ones, you got to see how to do them in a calculator. Next, we've got 2 cosine 2x minus square root 3. So there's an interesting thing here because of this 2 in front of this x, and this is where these ones can get extra difficult. So I'm adding the square root 3. I get 2 cosine 2x equals square root 3, and dividing by the 2. Now keep in mind when you divide by this 2, you're dividing the coefficient by 2, but not the argument. So it's still cosine 2x equals square root 3 over 2. At this point, cosine is alone. So what I'm going to do now is go to the unit circle, but what I'm solving for is not x, it's 2x. So, and you'll see how that pans out. If I go to my unit circle, cosine being root 3 over 2 happens here and here. If I think about these locations, this is pi sixths and 11 pi sixths. So I would say x equals pi sixths, x equals 11 pi sixths. But this is not us solving for x. It's us solving for the angle of cosine, which in this case is 2x. The period for a cosine function is 2n pi. So now you look at this and you say, well, these are 2x. I want to know what x is equal to. So you divide everything by 2 and divide everything by 2. So this gives me x is equal to pi twelfths plus n pi. And x is equal to 11 pi twelfths plus n pi. This one cannot be simplified, and you can see it sort of graphically why it can't be simplified. If I was going from this point all the way to this one, that's a huge angle. But then to go from this point back is a very small angle. The only time in which it can be simplified is if these arrows, these distances between these, are going to be the same regardless of direction. So I know just visually it will not be something that I can simplify to just one general equation. So you get this equation, which would give you all points that would fall here, and this equation that would give you all points that would fall here. All right, just one more example. This last example, it says use a graph. So we're gonna wait, do this one in class. Don't write in class really big here because I'm gonna still do the problem, or somebody's gonna do the problem, and you're gonna wanna write things down, maybe. So solve for x. We've got cosine 2x times 2 cosine x plus 1. Now, right now, this is already written as two separate factors. So it's sort of like a problem going back to here when I have two factors and I set each one equal to 0. That's what I'm going to do here. Sorry, too far. I get cosine of 2x is equal to 0, and 2 cosine x plus 1 equals 0. So I'll do this one first. It's a little bit easier. If I subtract the 1 and divide by 2, I get cosine x equals negative 1/2. At this point, cosine is alone, so I go to my unit circle. Cosine is negative 1/2 here and here. I can tell right now, just looking at this, it is not going to be something that simplifies down to one equation because the distance going this way and the distance going this way are not the same. Just think about like if I was drawing this little sort of half circle versus this half circle, they're going around a different amount of angles. So this point was 2 pi thirds. This point is 4 pi thirds. And the period of cosine is 2n pi. Again, visually, you're thinking about the only way in which I'll get to this point over and over and over is if I keep adding revolutions of a circle. The only way I'll get to this point over and over and over is if I keep adding revolutions of a whole circle. So we've got those two solutions, but we also have the two solutions, or one solution, or however many solutions, come from cosine 2x equals 0. So at this point, cosine is also alone. So we talk about where is cosine 0, which would be here and here. I can tell right away this can be written as one general equation because the distance going this way is the same as the distance going this way. And if you want to think about that other ways, that's perfectly fine. If you want to play with it in different ways, that's fine. It's just one way in which I like to think of it. So this angle is the only one I'm going to talk about. This is pi halves. So I would have 2x equals pi halves plus, and because I'm going and saying, okay, I'd only have to go here and then here, this is a revolution of pi, not 2 pi. So this is pi halves plus n pi. Because I don't have to go around a full revolution of a circle like I did here. And in this case, I can divide everything by 2. I get x is equal to pi fourths plus, this is written as n pi halves. So we've got three solutions here, 2 pi thirds plus 2n pi, 4 pi thirds plus 2n pi, and pi fourths plus n pi halves. Again, starting off, what you want to be able to do is just be able to get the 2 pi thirds, the 4 pi thirds. Then you want to work towards, okay, well, what is the period of this? The plus 2n pi. And then you have to pay attention to cases in which you have 2x or 3x, 4x, 5x, and cases in which you can simplify it, cases in which you can, do we have one? We had one somewhere. There we go. Cases, nope, in which you can simplify, some of those points into just one equation. So those are the things that you want to be looking for throughout all of these problems and working towards getting more and more of those skills. First, just start off with being able to get those angles, then deal with the period of them. All right, again, make sure there are some stuff that we have to go over in class, so pay attention for those. Jot down any questions that you have or get started on 5.3 homework.